Finally, we are already in our seventh or the last problem for our kinetics of particle discussion. So in Hinay, we started from horizontal and then from horizontal with constant force and then from horizontal with a increasing force. And that is a function of our distance or displacement and a function of time. And then we have a simple incline. And then we have a combination of an incline and the projectile. Now, this is similar with our horizontal motion, just that instead that the force is given, the force P or the unbalanced force is given in this one, we need to find the magnitude of the force P. Okay, so let's start or proceed with our discussion. We have here a mass, a crate again, 50 kilogram crate starts from rest and achieves a velocity of v is equal to 4 meters per second when it travels a distance of 5 meters to the right. Here, the motion is explicitly mentioned that it travels to the right. Determine magnitude of force P acting on the crate. Coefficient of kinetic friction from the crate and the ground is mu k is equal to 0.3. So in this one, we have a kinetic friction. Therefore, we need to consider the summation of forces along y at ang masong na to si force P. Now let's write our given. We have a mass equal to 50 kilograms. Starts from rest and achieves a velocity of 4 meters per seconds when it travels a distance of 5 meters to the right at s is equal to 5 meters. So this is a function of our displacement. Determine the magnitude P. So what is the P? And then we have our coefficient kinetic friction is equal to 0.3. So what else can we have here? Okay, that's all. Now motion or acceleration is towards the right. So if we draw an FBT for this one, we have this is our x, this is our y. We have a force P at 30 degrees. And then we have a friction, oh, by the way, we have a friction F is equal to 0.3 times the normal force. So we have a force F here. We have a normal force, NC here. And then we also have our weight. Our weight is just the 50 kilograms as 9.81. That is equal to 490.5 newtons. So after establishing our free body diagram, then we try to solve or we try to sum the forces along x and along y. So with this one, we try to sum first the forces along y. Summation forces along y is equal to 0 because there is no acceleration along the y. So we have the normal force minus the weight plus our force P, which is equal to P sine 30 equal to 0. So we have that our normal force is equal to the weight 490.5 newtons. Let's remove the newton minus P sine 30. Say this is our equation 1. We sum forces along x is equal to mass times the acceleration. Forces along acting along x, we have P cosine 30 minus frictional force is equal to 50 times the acceleration. We substitute our frictional force. We have P cosine 30 minus 0.3 and C is equal to 50 times acceleration. So we can substitute equation 1 from to this one. So we have P cosine 30 minus 0.3 times 490.5 minus P sine 30 is equal to 50A. So simplifying, we will have 1.016025 P is equal to 50A plus 147.50. Next, so may apply na to next. So next thing that we're gonna look is that if the magnitude of P is constant or not. Obviously, there is no indication here that the force P is increasing, and we can assume, or it shows only that our acceleration is constant. If our acceleration is constant, then we can apply the constant kinematic equation. But which among them? We have the initial velocity, we have the final velocity, we have the initial distance, and the final distance. So what else do we need? There is no time here, then we can use this one. The square of the final velocity is equal to the square of the initial velocity plus 2 times the acceleration times the displacement. So this is our 5 minus 0. So we have 4 squared is equal to 0 plus 2a times 5. From there, we can get that our acceleration is equal to 1.6 meters per second squared. Now we just substitute the value of our acceleration there, and we try to solve for p. We can arrive that our p is just equal to 223.567 Newton. Then this will be the answer. This is the magnitude of force P acting on the plate, sufficient for it to move towards the right. Less than ani, dili mo move si plate. I hope you understand the kinetics of the particle and understand and appreciate that forces acting on a specific particle or an unbalanced force that acts on a specific particle or object causes the object to move. And since it causes the object to move, the object will have its acceleration. And the acceleration or the motion of the object is towards the line of action of the unbalanced force. So malala siya. And then, it's important na aron dili mo malibog so that you will not be confused is that you try to write the things that are given and to write what is been asked. First is that, and then afterwards you draw or try to draw the free body diagram. If there is no kinetic friction, then therefore we need to consider the normal force acting that perpendicular to the surface and then the frictional force. Then diretso na mo, pwede na mo diretso to solve the summation of forces along x. Else, if the frictional force is considered, then you need to solve for the summation of forces along y. Now, the problem is, another thing also is that you need to see if the acceleration is constant or non-constant. In order for us to have an easier way to solve to manipulate the problem because we can apply the constant kinematic equation to this one. And also, if the surface is inclined, then what do is we try to apply the rules of our kinetics of a particle on the inclined axis. Ano lang. And then also, same also the kinematic equation which you previously learned, you can also apply that on an inclined surface instead of uh, getting the components of the inclined surface. Another thing, if the object or a particle already slides away from the horizontal surface or inclined surface, then the object is already considered a projectile. And then from that moment on, we can apply also the acceleration of a projectile, which is the acceleration only due to gravity. Also, take note of the units you're going to use, if it is in SI or in imperial or English units. So that's all for our discussion on the kinetics of particle, and hope you learned something for this one. If you have any question, already know what